Alright, in this video we are going to learn how to list the possible rational zeros or roots using something called the rational root theorem. Now, because the degree is 3, we know there are 3 actual zeros. That's not what we're talking about right now. We're talking about if we had to do some trial and error and make some guesses hunting for those 3 roots. Would we need to just guess every possible number, like 1, 2, 3, 4, 5, 6, 7, 8, 9, and negative 1, 2, 3, 4, 5, 6, 7, 8, 9? Or can we narrow down that list of guesses to a shorter list? And that shorter list of guesses is what we're calling the possible rational zeros. This does not include imaginary or radical zeros, which do happen, but accepting that, the rational root theorem says that all of the possible rational zeros are going to be in the form p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. Here's what that means. If I want to make a list of the possible rational roots, I think of it in terms of numerators and denominators. Okay, numerators and denominators. The possible numerators are going to come from the constant term. All right, the possible numerators are going to be factors of 8. So what are the factors of 8? Well, 8, obviously 1 and 8 are factors of 8. But other than that, we have 2 times 4. So we have 2, and we have 4, and we have 8. Okay, so the possible numerators will all be factors of 8. Now the possible denominators are all going to be factors of the leading coefficient. All right, the possible denominators are going to be factors of 2. The only numbers that divide into the number 2 are 1 and 2. So to make a list of the possible rational zeros, I'm just going to mix and match these numerators with these denominators. Now, we want to do this in a systematic way, so I recommend taking one denominator at a time. So let's start with a denominator of 1. So I'm going to put all of these numerators over these denominators, over this denominator. So 1 over 1, 2 over 1, 4 over 1, 8 over 1. Well, you know, if I put 1 over 1, that's just 1. And similarly, 2 over 1 is 2, 4 over 1 is 4, and 8 over 1 is 8. Okay, so I put all of these numerators over this denominator. Now to help you see it, I'm going to change colors. So now I'm going to use the denominator of 2. So I'm going to go back again and do all of these numerators over this second denominator. So I'm going to do 1 over 2, 2 over 2, 4 over 2, and 8 over 2. So 1 over 2 is 1/2. So I'll write that down. 2 over 2, wait a minute, that reduces, doesn't it? What does 2 over 2 reduce down to? All right, 2 divided by 2 is 1. Wait a minute, we already have 1. I don't need to write it again. So I won't write that one. What about 4 over 2? 4 over 2 is 2. Okay, we already have that, so I don't need to write that again either. What about 8 over 2? 8 divided by 2 is 4, and we already have that. I don't need to write that again. So we only got one new possible root from the denominator 2, and that is 1/2. Now, what about the sign? You might have noticed I didn't say -8. That's because all of these roots could be positive or negative. So I'm going to go back and put a plus or minus in front of every one of these. Okay, so if I had to guess and do some trial and error to try to hunt for my 3 actual roots, I would start with 1 and negative 1, and then I'd try 2 and negative 2, and then I'd try 4 and negative 4. I would not try 3 or negative 3 because that would not be a possible rational root. All right, and if those didn't work, I wouldn't try 5 or 6 or 7. I would skip to 8. Okay, so that's how you make so this would be a list of the possible rational roots. All right, so that means if we were to solve this problem and find out what the actual roots are, unless those roots are imaginary or unless they involve square roots, they should be somewhere on this list. They should be among these. All right, let's keep going. So again, now I'm going to do these remaining problems a lot faster because I did the first one nice and slow. If I want to make a list of the possible rational roots, the possible numerators are going to come from the number 9. They're going to be factors of 9. So possible numerators, possible denominators. The numerators will be factors of 9. So of course 1 is always a factor. And then 9 is 3 times 3. Okay, so those are the factors of 9. 1, 3, and 9. The only numbers that divide evenly into 9. The possible denominators are going to be factors of 3. So the possible denominators are going to be just 1 and 3. Okay, so as I build my list of possible rational roots, I'm going to take one denominator at a time. Let's start with a denominator of 1. 1 over 1 is 1, 3 over 1 is 3, and 9 over 1 is 9. So I've used the denominator of 1. Now I'm going to use the denominator of 3. 1 over 3 is 1/3. 3 over 3 is 1. We already have that. 9 over 3 is 3. 9 divided by 3 is 3. We already have that. So all I need to do is put a plus or minus on each of these. So these are the only possible rational roots, the only possible roots other than imaginary roots and square roots. So again, if I had to do some guessing, you know, guessing and checking, especially imagine that I didn't have a calculator, so I couldn't just make a table and look for these. If I had to do it by hand, which is what we're building up to, these are the only guesses that I would make. So number 3. Again, if I want to build a list of the possible rational zeros of this function, I'm going to think of it in terms of numerators and denominators. All right, the possible numerators are going to be factors of 4. So that is 1, 2, and 4. The possible denominators will be factors of 9. So that is 1, 3, and 9. So as I build my list, I'm going to mix and match these numerators with these denominators. But I'm going to be very systematic and use one denominator at a time. So 1 over 1, 2 over 1, 4 over 1. Oops. Okay, so that's it for the denominator of 1. Now I'll do the denominator of 3. So 1 over 3, 2 over 3, and 4 over 3. Okay, now I'm going to move on and use the denominator of 9. So that's 1 over 9, 2 over 9, and 4 over 9. Okay, so this is the entire list of possible rational zeros, except for the fact that each of these could be positive or negative. So don't forget to put a plus or minus on each one of these. All right, let's do one more. We're going to list the possible rational roots for this function. So again, we're going to think in terms of numerators and denominators. The possible numerators are going to be factors of 24. All right, the factors of 24. You know, 1 and 24 are obviously factors of 24. Other than that, sometimes it helps to make a factor tree. So for example, 24, you know, is 2 times 12, okay? And so there I've got 2 and I've got 12, but then 12 is going to be 2 times 6, and then 6 is 2 times 3. Okay, so just doing this process just helps you think about what all the factors are going to be. In fact, you know what, maybe I won't do it that way. Let's just think about all the ways I can get 24. Okay, so it could be 2 times 12, or it could be, 3 times 8, or it could be 4 times 6, or 1 times 24. All right, I think that's all of them. So every number on this list is going to be a factor of 24. So I've got 1, 2, 3, 4, 6, 8, 12, and 24. I'm going to need a longer line. Okay, 6, 8, 12, and 24. All right, 24 has a lot of factors. All right, now the possible denominators are going to be factors. Okay, so those are numerators. The possible denominators are going to be factors of the leading coefficient. But in this case, the leading coefficient is just 1. And the number 1 only has one factor, and that's 1. So the only possible rational roots are going to be these numerators over this denominator. So that's just going to be the same list. So that's just going to be plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, 8, 12, and 24. Okay, so these are the possible rational roots. Now that didn't narrow it down very much. If we had to guess and check, if we didn't have a calculator to just look and see, you know, at least the whole numbers show up on the table, we would still have a whole bunch of guessing to do. But anyway, that's how you can make a list of the possible rational zeros. So once we find the actual 3 roots that there are, because we know that there are only 3, unless they are imaginary or radicals, you know, square roots, they should be on this list somewhere.